Throughout the history of Earth, it has been marked with periods of extensive cooling. One of these periods occurred 700 million years ago, and was so expansive and destructive that it saw ice spanning most of the entire globe, known as the Snowball Earth event, prompting Earth to be covered from head to toe for tens of millions of years in thick ice sheets. Later in Earth's history came the Mesozoic era, which witnessed the reign of the dinosaurs, spanning a remarkable 160 million years. This era is categorized into three distinct periods: the Cretaceous, Jurassic, and Triassic, each lasting approximately 50 to 80 million years. But their time would come to an end, leading to the mass extinction of the non-avian dinosaurs. Following their extinction, the subsequent era, known as the Cenozoic, is categorized by the dominance of mammals. This era has persisted until the present day, and has spanned the last 65 million years. Throughout its duration, the Cenozoic has experienced extended periods of intense cold, culminating in what we recognize today as the Ice Age. An ice age signifies a prolonged period during which the Earth's temperature undergoes a significant decrease, resulting in the formation and expansion of extensive continental polar ice sheets. Another term used interchangeably with ice ages is a glacial period, signifying a phase in which the Earth's temperature is on the decline. Conversely, there are warmer intervals marked by the melting of ice caps, or the absence of ice caps, known as interglacial periods. Over the 65 million years during which mammals have held dominion as the apex predators on Earth, the temperature has been gradually lowering for about the last 30 million years, accumulating in the Quaternary glaciation, or what we typically refer as the most recent ice age, marking the period between 2.6 million years ago and today. Considering that mammals have governed the Earth for a mere 65 million years, and dinosaurs dominated for nearly 3 times that duration at 160 million years, it prompts a reasonable question. Did dinosaurs also experience ice ages during their reign? To find the answer to this question, there are a few things to consider when examining the formation of ice ages. The first and largest consideration are greenhouse gases. Greenhouse gases are the gases in Earth's atmosphere that trap and absorb heat, contributing to the overall raising in temperatures around the world. The most prominent greenhouse gas in the atmosphere is carbon dioxide, which contrasts to that of the two other most prominent gases in the atmosphere, nitrogen and oxygen, that do not absorb heat and in turn do not contribute to raising temperatures. That's why you hear so much panic about carbon dioxide today, because of the relatively massive increase in carbon being released into the atmosphere since the Industrial Revolution, though it's not entirely proven to be the only cause in this carbon shift. Anyways, we measure this through considering carbon dioxide's parts per million, or the number of carbon dioxide particles in 1 million parts of air. The higher the number, the more carbon in the air, corresponding with higher temperatures on Earth that come from the increased heat absorption of the carbon. Currently, the Earth sits at around 416 carbon parts per million, which has increased drastically from 280 parts per million just a few hundred years ago, and even more from the 180 parts per million that were present during the beginning of the Quaternary glaciation. So with the correlation of low temperatures and carbon in the atmosphere now understood, how much carbon was in the air during the dinosaurs? As I said before, the time of the dinosaurs is marked as 3 distinctive periods, and each period has its own average carbon parts per million. But even still, the amount of carbon in the air at the time was massive compared to today. For instance, during the Triassic, the atmospheric carbon dioxide levels rose as high as 4,000 parts per million, which is 10 times higher than what we have today, and anywhere between 1,000 to 2,000 parts per million during the Jurassic and Cretaceous respectively, meaning these higher carbon amounts led to elevated global temperatures. But what caused these elevated carbon levels? Lots and lots of volcanic action. As volcanism takes effect, it spews loads and loads of carbon into the atmosphere. But what caused this huge increase in volcanoes? One thing that had a massive role in this was the breakup of the supercontinent Pangia, as splitting multiple continents from each other typically isn't the calmest of processes. The movement of entire landscapes and continents caused enormous volcanic eruptions that spewed climate-changing gases into the atmosphere, thereby heating the planet. But carbon is not the only factor to consider when examining the presence of mass glacial periods in prehistory. There are a few more notable features that will lead us to the answer of whether or not dinosaurs had ice ages, which brings us back to the topic of Pangia. Pangia was situated closer to the equator, where sunlight is more direct. In theory, this contributed to overall warmer temperatures. Moreover, due to Pangia's positioning, this also led to it being harder to form ice around the poles. The formation of ice and subsequently glaciers, is easier to occur on land. This is because land reaches the freezing point much quicker than water, primarily owing to the differences in their thermal properties. The ease with which ice forms on land has obvious implications for glacier formation, which initiates with the accumulation of snow. When the rate of snow surpasses the pace at which snow melts, the surplus snow compacts under its own weight and gradually transforms into glaciers. So with ice being harder to form because of the position of the continents, it leads to a vicious cycle where less ice equals higher global sea levels, which is obvious by looking at the sea levels of the Cretaceous, a period in which the global sea levels were 550 feet higher than they are today. And these higher sea levels, in turn, take away more and more land for glaciers to form and grow on. So this cycle once again feeds itself as less ice equals higher sea levels, and higher sea levels equals less land for ice. But there's another factor when considering the effects of less ice at the poles. Ice and glaciers actually make the global temperature colder. This is because of the white color of the snow, which reflects light and in turn heat back into the space, instead of absorbing it and heating the earth. This is known as the albedo effect. So continuing that cycle, less ice means more heat absorption, thereby continuing to heat the earth. There are also some other ways that the shape of the continents affected the world's overall temperature. Pangia blocked a lot of moisture to get into the inner continent, and because of this, plants had a hard time growing, breaking one of the chains that controlled the CO2 levels around the world. This is because plants need to take in CO2 from the atmosphere so they can undergo photosynthesis. So Pangia blocked a valuable carbon sink for the Earth, and only further increased the Earth's temperature. But as Pangia broke up, it also changed the currents of the ocean, separating and halting currents around the world that would have otherwise made the ocean warmer. For example, this very reason is why Antarctica had ice on it 40 million years before the North Pole. The blocking of these currents trapped colder currents around Antarctica, and more as the continent split and North America and Eurasia closed in around the Arctic Ocean, the waters up there also were cut off from the warmer currents, making that area colder and colder. In conclusion, the greatly higher greenhouse gases made the Earth of the past a much warmer place, along with the position of the continents, which played several critical roles, making it harder for plants to grow, killing a crucial carbon capture mechanism for the Earth. The effects it had on the currents and ice formation all led to the fact that Earth was much warmer in the past than it is today. So when taking all these considerations into factor, did the dinosaurs have ice ages during their 160 million year reign? Unsurprisingly, no. Considering our aforementioned reasons, so sorry guys, I'm sorry to let you down, but Ice Age Dawn of the Dinosaurs would and could never have happened, sadly. Although it would have been pretty awesome. So all these factors totaled into the average temperature experienced during the Mesozoic to be much higher than it is today. The average global temperature was about 6 to 9 degrees warmer than today, and these temperature increases allowed the Earth to stray away from any large-scale ice ages during the reign of the dinosaurs. If you guys liked that video, please like and subscribe. I'm making one video a week, and your guys' support makes everything so much more enjoyable. If you have anything you want to add or correct with what I said previously, let me know in the comments. I read everything. So, guys, thank you for watching, and Jehona out.